Hi everyone, in this video, let's discuss this problem LRU Cache. Design a data structure that follows the constraints of the least recently used LRU Cache. Implement the LRU Cache class LRU Cache int capacity. Initialize the LRU Cache with positive size capacity. Int get of int key. Return the value of the key if the key exists, otherwise return -1. Void put into key into value. Update the value of the key if the key exists, otherwise add the key value paired to the cache. If the number of the keys exceeds the capacity from the operation, evict the least recently used key. The functions get and put must each run in order of 1, average time complexity. As given in the problem description, we can see here the class LRU cache is given, and we can having the public int get. We need to complete this get method and put method, but both the complexity is should be order of 1 as is being asked in the problem statement. Now what they are given, your LRU cache object will be in- initiated and called such LRU cache object is new LRU cache of capacity. So given an example, right? First, if they given LRU cache, that means the size they two, we initialize that here the capacity. First we'll initialize the capacity, and then it's like they call object dot get and also object dot put. Object dot get will get by key, object dot put they get by key value. If you see here LRU cache, first capacity 2, then if they say put 1 comma 1, we need to put 2 comma 2. So first put 1 comma 1, the cache is 1, then put 2 comma 2, cache is 1 is 1, 2 is 2, and get 1 means we need to return 1. So the LRA key was 2, so it will affix the key to cache is 1 comma 1 and 3 when you try to do 3 comma 3. And when you do get 2 reruns, if it is not found, return -1. Put 4 comma 4, key was 1, affix cache is 4 comma 4, 3 comma 3, and get of 1 reruns -1 not found, and get of 3 return 3, get of 4 return 4. Let's try to understand this problem properly. First, what is this least RAU? Here, so LRU cache, it's work like I'll show you an example. Suppose you have a bookstore, or you have a table. So on the table, you can hold only two books. The capacity is only two. So what you will do? First, you will put the book one, and again you will put the book two. So the left side is the most recently used one. So this is the most recently used and is the least recently used. This is the concept of that LRU. So our agenda is, since you use book one, suppose you if you use the book one, so you it is the again recently used, right? You need to remove this, you need to put at the one. So like this, whenever you try to book the put the table book three, so three you are using red, the table is full. So the rule is first you need to remove the two and should put the three. So it's like you have a library, but we have a most used books. So like lot of books will be there, and which book should be removed here is like whatever least recently used. So here the thing is we use the two things here. The first thing is we need to use the hash map, because the get and put the operation is order of 1, and whenever also we are using here the doubly linked list. Why? Because we are maintaining the order, the linking that we are maintaining. And if we see here, uh, a simple idea is we have a hash map. Suppose 1 is representing node 1 and 2 it representing node 2. So first also we will have the node head. So we will add a header node and we'll put the value, suppose 3 comma 1, and the last will have a tail. The tail and head is like a dummy nodes. So for our convenience, so these are the LRU cache. Immediately we need to think about use a hash map and doubly linked list. So the code something is like, I'll we can discuss about the code now. Okay, now if we talk about the code, first what you are doing, class node. The class node, you have key value and the node previous and the node next, and the node you have int key and int value, and the capacity is you're taking and hash map of integer, and that points to node, and you have node head node tail. Then after that we have the code. The code follows like, first we are following that void add to friend. So whenever, so we have a situation, right? Whenever you're adding a new element, we need to add the friend. So that is add to friend, that is node. So node dot nest head dot nest, and node dot previous is equal to head, and head dot nest dot previous node, and head dot nest is equal to node. And and whenever you want to get, so if it is there, if map dot contains of key, if it is not there, you will return -1. If it is there, you will just node of node map dot get of key, and you need to remove it. So how you will remove it? The remove is, if you see here, node of node, right? So you need to remove the node dot previous dot nest is equal to node dot nest, and node dot nest dot previous node dot previous. So whatever the current node dot nest and node dot previous, you just removing it, is like a linkage. And and similarly, when you are trying to put, if it is already contains, uh, so first, whenever you're trying to put, there is a two chances. First of all, if it is contains, right, you will remove that old node of with that will remove. Or if the size is full, it is a new element, and by the time itself the size is full, so that time also you need to remove the last node. And if and however, we need to add it at the front. I'll give this as example. So like we are discussing here, first we are creating a node, and we are setting an variables, and we are try to insert at the front and remove the node and get. These are such activity. The entire idea is, first you are trying to insert the node, which is put the node after the head. So we are the head, right? Before we'll put the node. If you try to remove the node, remove any node, so the given node, get the key. So find, if you want, if you try to do the get of key, first to find that in hash map, then you can remove, plus also you need to reinsert and put. So whenever you're trying to put a key of value, if it is full, you need to remove the tile dot the previous one, then insert new node. So the cache means, a cache is like a small fast storage that keeps the data you use often. So things like I said, there is 100 books, but your table can hold only 3 books. So you need to have a pick the faster. So what you do, you will put in what is you're using very recently. So the LRU means here least recently used. So that we already discussed. Now when it is useful, suppose you open a Gmail app and YouTube app and LeetCode app. These pages are stored in a cache. Suppose later you open Amazon, Netflix, and Facebook. Suppose your cache becomes full. Which page should open now? So whatever you opened recently, that will be there. So in it removes the page that you are not visited for the longest time. That is called LRU. So this was the example. LRU is a fixed size storage that always removes the least recently that used item when it becomes full. So the cache is follow like that. So you will have a head and you will have the items 7, suppose 5. These are the that key node, and you have the tail. So head and tail is like a just for helpful. So the code we already discussed here. First the values, right? Node. So example key is a 1, value is 100. Node stores key value and it also store node previous node nest. We store both key and value. And why previous and node? Because it's created doubly linked links, like node 1 is connected to node 2 and node 2 also connected to node 1. So each node knows which is connected to previous node and next node. It helps us remove any node quickly. What is hash map? The hash map I'm using here, key is a key and value as a node. And we when you call get of 2, so immediately we'll get us the node for the KKT. What are head and tail? So the head and tail are just a dummy nodes as we discussed. They do not contain real cache data. They make insertion and deletion easier. And we have a constructor. So the constructor LRU cache int capacity, capacity map new hash map head new node tail head nest. So it is at the first time initialization. So we'll create the map as empty and capacity 2 and head and tail. Then try to you should understand add to the friend. So this method puts the node immediately after head. Suppose the current list is head 2 comma 1 comma tail something. When we try to insert, whenever we try to insert, so node dot nest, that is we try to insert a new node. So that 3 dot suppose we want to 1 and 2 is already there. So if you want to insert 3, 3 come first, the 3 dot nest will be 2, and this 3 dot previous will be head, and 3 dot the head dot nest dot previous node, and head dot nest is good node. So exactly the node 3 knows that previous node is the head and the next node is head dot nest is node. So after try to understand remove, whenever you try to remove it, the same applies here. The remove also, whenever you try to remove, here also you are doing the same. Suppose you have elements like 3, 2 and 1. Before you have head and last you have the tail. So you are giving the which node to remove, right? So node 2 as given, suppose I want to remove the 2. So what first line is do, so suppose you want to remove the node 2. So node dot the first line is node dot previous dot nest is equal node dot nest. That means, so node 3 dot nest is 1, and second line is node dot nest dot previous node dot previous, that is node dot nest dot, so 1 dot previous is 3. So you are eliminating 2. That's it, simple logic. Understand the get element. So when you're trying to get, suppose cached is head comma 2 comma 1 and tail. So you want to get the, suppose you try to get some value. So that suppose you want to get the 1, so 1 is there. So if it is contained, if it exists, 1 exists, it will continue. If it is node, so given node is now node points to the, so here the node map dot get of key, and also will remove that node and put it the add to front. And understand the put, there is a three situations in the put. One thing is, suppose cache contains, get the old node, remove it from linked list, remove it and from the map. Cache is full, suppose capacity is 2, so add the new node at the last. So the complete example, let's just do it. Understand the complete example. Suppose you have suppose the capacity is 2. Create the node 1 head 1 and tail. So you put 1 comma 10, and now put 2 comma 20. So that is head 2 will come before 1 and tail. Now get off 1. So node is used, so move it to the front. So you need to move head like 1 and 2 and tail. So it will return the 10. Suppose you want to put 3 comma 30. So that least recently used node is u2, right? Which is tail dot previous. You need to remove that and then add a 3 at the front. How will you add? Head 3, 1 and tail. And now you want to get the 2. So 2 is not there, right? It will return -1. So easy memory rule is for get, what you are doing, first you will find, then you will remove and move to front and return. For put, what you will do, first you remove the old key if present and remove the LRU list, the last one, if it is full. Create new node, add to the front and put in the map. So the time complexity of get is order of 1 and time complexity of put is order of 1. Yeah, let's try to run this code here. So the same code, LRU cache, class node, initialize capacity and LRU cache constructor and remove, add to front. These are the methods get and put. Let's run this and let's submit. Yeah, so this is how the code will work. You can check the code.